So we're beginning our study of logic. And the way we're going to do that is by building a precise logical language. We're going to take English as our guide, a natural language like English as our guide, not because we want to just emulate English, but rather because it's a language that you and I share, and we can use it as a guide for the kinds of things that we would like to be in our language, and also for the kinds of things that we would hope are not in our logical language. Now, even saying that, however, what should we choose as our starting place in English? Where shall we start? Well, English has so many different things in it, right? It has nouns, verbs, adjectives, many different other elements to this natural language. But it is traditional logic, and it seems like a very wise move to start with sentences. And in fact, this logical language that you and I are going to build, this precise logical language, is traditionally called the propositional logic, or also the sentential logic. And both of those names really just mean the sentence logic. So we want to start with sentences. Later, we can try to break into sentences and say, what are their parts? But for now, it's best if we start with sentences. So we've agreed we'll start with sentences, that our logical language, the propositional logic, will have as its smallest parts sentences. But if we're taking a natural language like English as our guide, we have to ask what kind of sentences. And here I've got some examples on the board that I just made up of different kinds of sentences. There's so many different kinds of sentences you can say in a natural language like English. Some philosophers have suggested that there's no upper bound on the different kinds of sentences that you might be able to produce in a natural language. But here's some different examples that you'll be familiar with, right? What is your name? A question. Get the car keys. A command. Damn it. An expression of emotion, a curse, something like that, right? I swear to uphold the Constitution of the United States of America. A promise, an oath. Aristotle died in 322 BC. This one's of interest to us because whereas these others seem to be doing different kinds of things, this sentence is making a claim about the world. And in particular, the interesting thing about it is because of that, it could be either true or false. That kind of sentence, in fact, is what we're going to take as our model. That's what we'll use as the fundamental building blocks of our logical language, the propositional logic. And we'll know such a sentence, which we sometimes call a declarative sentence. We'll know such a sentence because it can be either true or false. You know, it doesn't seem that a question, what is your name? It doesn't seem that that could be true or false. A command doesn't seem like it's true or false. It's trying to get somebody to do something. It has a different function in the language. A curse doesn't make sense to say it's true or false, does it? Its role is different. It's a way to express emotion or something like that. An oath. Well, we could say, you might say somebody's oath is false, but I think what you really mean there is they didn't mean to keep it or they broke it. But it's really not, the sentence really isn't sort of describing anything. It's committing to something, right? Interestingly, consider something like in a wedding when you say I do. It's neither true nor false. Instead, it's really a piece of language that changes your legal status by creating certain kinds of promises, right? But this thing is different, isn't it? It's not doing these different kind of tasks that we're able to do in a natural language like English. Rather, instead, it says something about the world and it's either true or false. So that will be our model, declarative sentences. Now we've said we're going to start with sentences, and our logic will in fact be called the propositional logic, meaning the sentence logic. And we've talked about how there's different kinds of sentences in a natural language like English, but we're really interested in those declarative sentences, the sentences that can be either true or false. We're going to need to say more, though. We said we wanted our logical language to be precise. And what do we mean by precise? Well, we can sort of figure it out by looking at things that are imprecise. Consider this sentence. Rochester is near Buffalo. It does look like a declarative sentence, but when would it be true? When would it be false? The fact of the matter is that this sentence is vague because near doesn't have a clear meaning. Or rather, perhaps it has a clear meaning, but it's not clear when something is near and when it's not. There's no precise place which would stop being near. You know, is 60 miles near? Or then does that make 60 miles and a half mile far? Or at least not near? So that's what we call vagueness. We want to avoid vagueness. Vagueness is about fuzzy borders, right? This word near has fuzzy borders. Perhaps in a natural language, we really need vagueness because it's just too much work to be precise all the time. But in our logical language, the whole point is to be precise. So we're going to work hard to make sure there's no vagueness in our logical language. Look at this sentence. Tom stands by the bank. That sentence instead is ambiguous. What does bank mean? In a natural language like English, it's ambiguous. The word could mean a financial institution, or it could mean the side of the river. We don't know. So we wouldn't be able to tell whether the sentence was true or false. So the other thing we need to rule out is ambiguity. We could think also, not just about vagueness and ambiguity, I'll say as a sort of side point, we won't have to worry about it too much, but there are other strange sentences in a language like English that you can say and which we surely want to avoid. Logicians have always been interested in this one, which we call the liar. It's a very strange sentence. It speaks about itself and it says it's false. Of course, if it is false, then it's true because it says it's false. But if it's true, it's false because it said it wasn't true. And you see the problem. There's something peculiar about the circularity of the sentence, and it sort of explodes on us. So we definitely want to avoid things like this. What bothers us about these three things? What really bothers us is, in the case, as we said, of vagueness, in the case of ambiguity, what bothers us is that we can't quite tell when the sentence is true or false in a precise way. So that suggests what we really want to do is have a standard in our logical language about the truth value of the sentences in our logical language. As for this sentence, we think maybe what's going wrong here is that the sentence talks about itself, so we'll certainly not allow that either in our logical language. So we've said that the way that we'll ensure that our logical language is precise is that we'll not even allow any vagueness in the logical language, and will not even allow any ambiguity in the logical language. One way we can test for that and build it into our logical language is to have a principle that we're going to call a principle of bivalence. You can see in the word it's saying two values. Well, what are these two values? Truth and falsity. What we'll say is that every sentence of our logical language must be either true or false, never both, never neither. That's a bit redundant way of saying it, but I want us to be really clear in our heads about what it means for us. If there's a sentence in our logical language, and our logical language isn't built out of nothing but sentences, if we have a sentence of our logical language, no matter what the situation is, we're going to require that that sentence is either true or it's false. It can't be both true and false. It can't be neither true or false. It's going to be one or the other. And if you think about it, that's going to rule, this principle of bivalence is going to rule out vagueness, because vague sentences are, sometimes maybe they're clearly true, and sometimes they're clearly false, and then there's this middle ground, where they're sort of, I can't quite tell. And ambiguous sentences are true if you read them one way and false if you read them another way, so they're sort of, I don't know, are they both, are they neither, who knows, right? So let's just avoid that completely. We'll say, we demand that every sentence in our logical language have this principle of bivalence. And because of that, if any vagueness or ambiguity slips into the language, we'll recognize it because we'll say, oh my goodness, here we have a sentence that's not obeying the principle of bivalence, we had to go back and fix something. So from the beginning, we'll build this principle in. It sounds like a trivial principle, but in fact, what we'll see later, very shortly, for example, when we consider what's called the conditional, you'll see that it really does put some strong constraints on us as we build our logical language that are going to require us to answer certain questions and do things perhaps in a way we wouldn't quite do them in our natural language. We need to say one last thing before we start building our logical language, the propositional logic. What have we said so far? The propositional logic is going to be built out of propositions, sentences that can be either true or false. We're using English as our guide, but we're only really taking as our guide those sentences which have a truth value, which could be true or false. And we insisted that every sentence of our language in our propositional logic is only going to be made out of sentences. We've insisted that every sentence in our language be either true or false, never both, never neither. That's our principle of bivalence. But what I haven't done yet is define truth. What does this word true mean? Well, we're going to have to introduce some things into our logical language that we don't define or that we're not able to fully explain or fully describe. And those we call primitives, the primitives of our language. And truth is going to be one of these primitives. After all, it's a very difficult thing. How would I explain what this thing truth is? I could say it's not false, but what does it mean to be false? Seems I'm going to end up saying not true. So what we'll do is we'll take truth as a primitive. This doesn't seem to get us in trouble. Your understanding of truth and my understanding of truth is sufficiently good that we don't get confused when we talk to each other about it. So we seem to be in good shape here. And the work that it does in the logical language doesn't really require us to fully define it, in fact. We can define false, however. If we take true as a primitive, we can define false as that which is not true. So at least that we can get once we've taken truth as a primitive. So now we've sort of set the groundwork for building our propositional logical language. So what we need to do is think, how would I make more complex sentences? And that's what we'll turn to in the next sections.